My name is Kwesi Asante. As you can see over there, folks call me Quasi. And sometimes my German friends call me Kavazi. It's all right. Whichever way you call me, just let me know you're trying to draw my attention. I'm fine with it. So I am the technical lead for the software developer kit for the developer products in technical support. And coding programming languages from Java, C++, and C#. But I think Java is, I'm a bit more comfortable in Java than the others. As a matter of fact, I think God wrote the world in Java, so. All right, so we're going to be talking about some of the key advantages and some of the key benefits in the version 100 release, or Quartz release of the Runtime API. And this benefit kind of cuts across all the technologies that are actually supported on the Runtime SDK, in the Runtime SDK. So certain things or certain parts of the presentation will be much more tuned to the desktop environments, and certain other parts would be applicable to both mobile environment and the desktop environment. So a little bit of an overview of presentation. Let's see, got stuff going. Just a clicker. All right. So a little bit of an overview. Basically, we're going to be talking about the loadable pattern, which is a new kind of paradigm, a coding paradigm that was introduced in this version. Do a little bit of a demo, and then we talk about the next paradigm, which is the task. And it's kind of a bit old. It was part of the 10.2x, but it wasn't as detailed or even abstracted in the way that it's done now. And then we talk a little bit, if we have some time, we talk a little bit about the some of the workflows and the data workflows that are quite important. And some resources as well. I have an app, a demo app prepared that I'm going to actually share with everybody on GitHub right afterwards. Just go on there, fork it, and give me comments. If there's something in there that you think is absolutely terrible, let me know, and I would try to respond. So, what is the loadable pattern? It's basically a paradigm that has been introduced in the current version that basically allows us to harmonize the loading of resources. So resources such as feature layers or stuff that you actually have to load from either the disk or from a network. And the paradigm is such that it allows you to asynchronously load their metadata and be able to query the metadata when the resource is actually fully available or loaded for you to deal with. The other thing is also that the resource allows, or this pattern allows for a mechanism for you to reload the resource if there is some kind of a problem in the loading. Say there's a network error or it's an I/O issue on a disk, you'll be able to do that. So I'll kind of touch a little bit about that as we go ahead. And then it also allows for you to get the state of the particular resource that you're talking about. Now, the API itself has over 70 different classes that actually implement this. Those classes that implement the loadable interface when it comes to the Java API, or the iLoadable interface in the .NET or the C# area. And I think same thing with loadable for Qt or the QML. They are all called loadable resources or loadable classes. So they all are loadable. Now, to get the status of a loadable resource, you can't just get load status on the resource that you're actually talking. If it's a feature layer, if it's a geodatabase resource, or whatever resource that you're doing, just get load status, and you can get any of these for load statuses. Now, this diagram here is actually available on the website, so you can take a look at it, and it kind of explains in a much more pictorial form how the loading is done. So when a resource is not loaded, it's actually in a state where it's sitting on there, it's actually not loaded. Its metadata is sitting on disk or in the network environment where you don't have access as the programmer to all those other information. Now, when you call load or load async on it, it enters the loading state where it's in the process of actually loading. So at this state, you can call cancel on it. The most important thing that you should be aware of as a programmer here is that calling cancel on any other state apart from the loading state does nothing to it. I mean, you're not going to get an error, but it really doesn't have any effect on the resource or the loading state of the resource. So, I mean, it's something to be aware of, that you might not, do certain things in your logic. You don't want to include those things there so that you don't falter. The other part of it, which I think is cool and really powerful, is the retry loading async. Now, there is a method or there is a paradigm in the API that they've basically made in such a way that we cascade the load resources or the calls. So if you have one method, a load async already called, and you call another load async, maybe the next few lines on it, what it does is that it cascades the calls, and you're not really going to reload or load again another instance of the same resource that you're trying to load. So it's very important, because this actually becomes very, very important in a case where the instance of the application or the resource that you just loaded, say a feature layer, is going to be used by a certain part of the application, right? Say you have a portal, you logged into portal, you want to search different parts of it, right? This particular portal item that is actually loaded, you don't want to call load again on it, right? Because then another part of the application that might be loaded might have a different state of it. So the mechanism is such that it ignores subsequent calls of load async. Very, very important. The only thing that you might want to do, maybe if you want to call load async multiple times, it's fine. It's just not going to do anything. Just tell your friends that I have 5,000 lines of code by calling load async 5,000 times. And so I'm going to go ahead and do a little bit of a demo here to sort of show the pattern in let me problem with the point. Okay. All right. So let's take a look at this application here. What it basically does is just shows us some of these patterns that we're talking about. So right here, we have several resources that you can show. If you want to add the data, for instance, browse for your data. And let's pick shapefile and load the shapefile. Now, this loads the shapefile from disk and displays it on the map for you. This is just a shapefile of the major roads in Ghana, which is where I'm from originally. So let's look at the code behind this that does that. Right? Just a quick look at it. This essentially is the code that does that, right? Here you have your shapefile, an instance of it created, and you pass it as the argument to the feature layer resource. You call load async on it, and the resultant of it is actually used in creating a feature layer that is added to, the feature layer that is added to. Let's get a feature layer here. That feature layer that is added, it's added. You check the status of it to make sure that it's actually fully loaded, and then you can add it to your map, and then check the scene and basically zoom to that viewpoint. The other thing that I wanted to show on this particular method is what I was talking about. If you are here, right, and you have the shapefile instantiated, what you want to do is call load async on that one, right? But it really doesn't do much, because that particular resource that you're going to be calling the load async on, you're going to pass it as an argument to another resource that you're going to call load async on it already. So calling load async here on line 315 and then having to pass that to the shapefile, the feature layer as a constructor argument really doesn't give you much, because when you call load async here on the feature layer, it makes sure that the resource that it depends on is loaded before this one is actually loaded. So it has that kind of cascading effect on it. So you can call here, the load async here, and call it again but it really doesn't matter. So that's why I commented that one to just show that. Okay, let's go back to the demo app real quick and show the option. Now, this is quickly, if you want to log into ArcGIS.com, the same approach, the same loadable approach. So here, I'm able to log in. I get my instance of stuff, just a little notification that tells me that. And then let's say we will look for a keyword on ArcGIS.com. This is just going to ArcGIS online, search for web maps, and then give me options on that. So here you can see the search is really quick. Now, I'm not really going to waste so much time trying to go to the code and show everything, but the approach here is an item is a loadable resource, or any kind of item that is on there, which web map is a type. Right? So these are all web maps that match the keyword fire. Now, to log into the portal item, or ArcGIS portal itself, ArcGIS Online as a portal, you have to call load async on that. Again, the portal item depends on the portal loading fully before you can actually display it. So that is also an example of cascading the loading effect of all these particular items, or all these loadable instances. So once you click on an item, maybe you can be able to zoom and go to the area of interest. Now, this same resource, or this same paradigm is kind of possible with the globe view as well. So here I just did something really quick to show once you click on here, goes to the disk, loads the scene layer, you're able to see stuff there. The same principle here. Nothing really fancy, nothing much going on. And the same principle being used in creating a route task or a route. Now, that is a task, and so we'll discuss it when we finish the discussion on the task part. So let's quickly go back to the PowerPoint. So the key benefits that you actually have is that you have the ability to write better error checking code, right? Because now when you load your resource, and the resource is not able to load, what happens is that there is a callback that is created for you at the end of the loading. So if you attach a listener to this particular resource and say, when you're done loading, give me this particular instance of it, a callback is created, and an error is actually populated into the callback. That callback can be given or can be queried for you to actually check the status of what happened. So now you can say, get load error, right? And then that gives you a throwable or an exception that you can actually query the message for, get an ID of it, and check whatever that means, right? So you can put this in a very strong logic in the application to check for all these kinds of issues. Now, your code is much better debuggable because now some of these things are in there. You don't really need to figure out why did my application fail, why did the resource happen. And if you really don't follow some of the paradigms in there, it will really trip you up. It's tripped a lot of people out. Some of the problems that we get, or the calls we get in technical support, are because most developers really don't understand the abstraction between the loadable itself and the real world, or how ArcGIS is actually trying to integrate them in the entire platform. And then you have a better understanding, like I just said, of the abstraction between the metadata and the resource itself. So the metadata is there. The metadata could be stuff like the extent, the name of the resource, and everything. Now, if you don't ensure that the resource has been fully loaded, and say you try to get the extent of it to try to zoom to it, you might hit a null pointer. Most important thing also to be aware of is whenever you call load async, you spin a thread. So that particular thread that you spun on there might not be the same thread that you're on when you're actually trying to do other concurrent stuff. So calling it and making sure that you're actually fully done before you use it is very important. You might hit null pointers, crash your application in certain ways that you're not really aware of. So those are very, very important things to do. And then, because of all these things that are actually baked into the API, you're able to write much better multi-threaded code. So multi-threaded applications are much better. You don't have to do all the nice stuff with writing new threads and putting your code on there to run. This is all done well for you. Okay. All right. So the next pattern that I'm going to talk about is the task and jobs pattern. Now, basically, it's more of having a resource somewhere, you attach something to it, and you want to be able to load it. Now, some of the tasks that we have geodata-based or locator route geoprocessing, which I think is the most powerful implementation in the runtime APIs right now, because it gives you the opportunity to use some of these supported, and some of them have to be, the geoprocessors or geoprocessing tool has to be supported before you can actually bring it in the runtime. There is a page that will give you all that. So you can perform really complex stuff, and I have an example here that we can look at. There. So there are two main implementations of this task and jobs pattern in the APIs or in the release. The first is one that really returns quickly. So there isn't much job or stuff going on in the background that's actually perform. So you can call these messages and they return quick. Some of them is just geocode is sync and all that. Let me just go ahead and see if I can do the demo here on that particular one. So this here, I'm just gonna go ahead and switch on that application. On my laptop is doing this, but should be able to come out of the PowerPoint. Switch. Okay. So if you say you want to be able to do a quick routing, or you click a certain point and say select another point, say let's say here for simplicity, and perform the routing, you're basically just getting these routes done for you. And this happens in a much quicker, and the results return quicker than you would have with why this should return right now. I don't know if we're having any exceptions here. Yep. Okay. Index. Let me rerun it again. Click another index. Performance. Okay. So once I'm done, we return, and then I have my routes. Like, finish loading, and we can see the routes here. Or we can perform another one. Let's do a check. Yep. So now we have our routes in here and everything, and you can see if you compare this to other tasks, it actually performs faster than the other ones that we saw. All right. Switch quickly back to the presentation and about the key benefits here. All right. So the other one is with ones that actually take a while to perform. So stuff with geoprocessing tasks actually do take a while. And so some of these, as they're going on in the background, you'll be able to query them and use the job to check the status of all the stuff that are actually going on. So the main paradigm is to first create your task, define the parameters, you call the method, and then you start a job. This is the main difference. The main difference between the first one and that one, you can start a job on this one, and this one you don't necessarily need to start a job on. And then you can use the job to actually get the status of all the other stuff that are going on. You can get the messages and everything. I have a demo here in the application that you can use to test. Kill this. And kill this here. And all right. Just happened. My laptop just went blank. Sorry about that. The laptop just went blank in the middle of my presentation. Interesting. All right. Good stuff. Okay. Stuff recovered from it. All right. So do a quick demo on that. All right, so go ahead and just do this. When you start the process, this is basically running a geoprocessing task that computes some contours and kind of displays them on here. Like I said, I'll share the application so you can actually go in and see all the examples of the code and everything. For the want of time, I'll want to skip actually going through all the steps in the code to actually see everything. So when it's done, that's what I need to show. It computes this, and it shows you the contours on the map, right? Now this was much more intense and much more. It took a lot more processing to do this. So while this was going on, you can get and query the status of all the jobs, and then populate to the user and show the user what was going on. Now let me try the example again, as it's a little finicky. It's going on, it's able to populate, get all the information, and then you can calculate the status of the task and tell the user what is going on. And now I'm actually getting everything, and then when the job is completed, I zoom in and then show the results to the user. So these are some of the key differences that come with some of the key aspects of the task. As one being an asynchronous and one being a synchronous task, one returning really fast and the other taking a while. Being able to use a job to get a status and display the information to the user. The other cool thing about it, and this is actually being handled with a local server. So the other cool thing about that is that we have a little REST URL that you have here. It's local to the machine. So you can copy that and then check that in the browser to actually see that the job that you just run. So this is just a submit job that I just run. And if I wanted to do the same here, I can just go ahead and then run the same thing. And then it's doing the whole execution for me, just like I was doing in the API in my code. You can check the status of everything here and be able to use that as well. You can check the result of your computing. It might take a while to actually bring the raster in the browser, but basically that is the two main aspects of the task API. The other one is the last one, I think, is with the key benefits of this. Now, because of some of these things that you have the ability to, the same way with the loadable pattern, you write better code, better robust applications. You're now able to basically leverage some of the powerful features of the ArcGIS runtime platform itself, offline, to write robust applications, really powerful GIS applications. Now, all the routing and all the preprocessing stuff that I was doing, I was actually not using anything online. Everything was local. So if you have an Android application that you want to be able to do now, the unfortunate thing is you can't do geoprocessing tasks on mobile devices because they require local server, and local server has to be installed as a different installation. Like I said, when you go to the example application, you have problems, just log an issue on GitHub and I'll respond quickly. This. And so lastly, the key workflows that we're dealing with. Basically, the most important thing is to look at is there is the offline data preparation type, and there's the services pattern, and then there's the desktop pattern. If you look at the desktop part, you're basically doing stuff with mobile map packages, preparing them, and they're only read-only stuff. You can't really do stuff and modify the desktop data that you're dealing with. So if you have a mobile map package and you have a logic to try to change stuff in there, you might want to consider the different pattern of preparing your data. And then the pre-planned workflow for the services architecture, or the on-demand plan workflow, or the individual workflow where you can actually use the API to move and shift around individual layers to work with. For the want of time and for fact I want to be able to give some time for questions, we'll move on to this part, which is basically the resources for the presentation. There's a lot of really good information on the developer side. It's one of the most, I think, underutilized websites in the entire company. So if folks need to go out there, please go on there. If you have any problems, let us know. Give us feedback. And I'm going to actually put everything on the Esri external GitHub page. And there's going to be a blog post that I'll be hosting this particular issue on. I'll update the contents of the application on the blog post, and the folks can go on there and see. Download, like I said, download the entire code base for this. Play around with it. Let me know the areas where you think could be improved, or where you think how I did certain things. If you're interested in finding out more, I'll be glad to share and then respond as well. Or you can just log a technical support case. Create a case. Ask that you want a specific issue here. You saw a demo here, and you wanted to follow up on that, and I'll be glad to assist in answering whichever question you might have. Now, if there are any questions, I would want to be able to see if I can answer some. Any questions? Wow. All right. Well, thank you for coming.